kind of compiling a bunch of things, like how many ways can Catherine run the race and just we know she's going to win, but how did it go yesterday?
It was pretty good. The timing system was like really messed up, so like there's definitely, but now we have to figure it out today.
So he stopped you in the middle of the race?
No, like
That'd be funny.
that, yeah.
Wait, wasn't that like an Antioch?
Yeah, so we have to go all the way back.
Oh my gosh.
That's awful. So the idea, bless you. The idea here comes with the working with how things can finish races, or how many ways can you select objects out of distinguishable patterns and stuff. So what I want to do is talk about what's called a permutation. A permutation is this idea, this thing called NPR. N permutes R. This NPR value is you have so many objects. All right, so you have 12 skiers. How many ways can 3 of them be? The first 3 can go through. It's a way that we write it out. 12 pick 3, 12 permute 3. Think of the 12 skiers total. How many ways can 3 top? How many ways can the top 3? How many ways can 3 finish? Well, if you're going to pick 3 of them out of the 12, how many ways can you get 3 of them to pick out? Well, that's where order matters. In your mind, you're thinking, well, if you're only picking 3 skiers out of 12, how many ways can the first person finish? They can finish first. There's 12 people who can finish first. There are then 11 people that can finish second, and then there are 10 people that can finish third. That's how many ways you can pick the top 3 finishers, if that makes sense. If you multiply that out, 12, 11, 10, oh, my computer crashed. I need to turn it off. I am no longer running any of those, what do you call it, Powerball simulators, because again, this morning I had it running. I was up to 2,500 years and whatnot, crashed the computer. So I'm done using those things. So you're on your own if you want to pick Powerball numbers. You multiply out 10, 11, 12, you get some number. I don't know what it is, but it's bigger than 11.
How long did you have it going?
Last year I had it going
For about a year or something like that?
not that long, but I had it quite some time. So basically there are 1,320 different ways that the top 3 finishers can be picked. Okay. So what that is that you're picking 3 out of the 12 where the order matters, and that's what's called a permutation. Now, a permutation in long form would be, I'm not going to yell it, this would be 12 permute 3 is what it would look like. I didn't yell it. Which would simplify out, if we did this long form, 12 factorial over, what was it? 12 minus 3 factorial.
Wait.
Well, 12 factorial is 12, 11, 10, 9, 8, so all the way down to 1. We okay with that? So let me show you what this is doing.
That looks like 12 times.
In essence, the space, are we okay if I did that as dot, 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 2 times 1?
Yeah.
Now, if I do the other thing, 12 minus 3 is how much? It'd be 9, 8, 7.
Why are you doing 2 times 1?
Let me show you that it goes 9, 8, 7, 6, 5, 4, 3, 2, 1.
Oh,
I know it.
okay, gotcha.
So when you look at that, what simplifies out?
Everything
The 10
Exactly. Everything below 9 simplifies out, and you're left with just this, which was, how many ways can you do that? But, wait, there's more. There's a button. There's always a button. Nope, no infinity button. Permutations are math. Is there a shortcut key I forgot? Is it alpha, zoom, function? Yeah. Alpha zoom left, go to function. Or alpha window, yes, thank you. And you'll see how it's 7, 12, key 3. Bless you. No. What is this, Soviet Russia?
Yeah.
In Soviet Russia, not like you don't do math. Grigori. My name is Grigori. Hey, I'm glad you're healing up so much better to get your license. So congratulations, and I'm very. Oh, you know what? You missed out on your hat.
I didn't get anyone yet.
You need a hat.
Do you guys know what time we get out?
I don't know why are you probably around
You weren't here to wear your hat yesterday, or the birthday hat of the room, so you have to wear the birthday hat for today. You're welcome. So happy birthday yesterday. So yeah, Sawyer tried to be you, but he wasn't quite as cool as you, because he didn't really own it. He tried to. I give you credit for it.
And then you try to pawn it off.
You are considering 10 colleges. Why not? Before you decide to apply to colleges, you want to visit some or all of them. In how many different orders can you visit 6 of the colleges or 10 of the colleges? So you want to figure out how many different ways can you go visit a college. There's a lot.
There's a lot.
Right. If you start thinking here, does order matter in which you go to a place? Because if you go to it, well, if you think about it, if you go to, let's say you have a list of colleges. If you go to the first college, are you going to go back to that one after you go visit the other one?
Maybe.
So you're just kind of picking them off that way. And this is where some of this stuff gets kind of fun. And I try to make sure that you guys you'll learn how it interprets it pretty quickly. So this is that the ordering matters where it's just a 10 pick 6 or commute 6 or a 10 commute 10, which is 10 exclamation point. Because what's 10 minus 10? 0. Now, one of the weird things about factorial is that 0 factorial will always equal 1. It's just one of those weird things. So if you throw this in your calculator, you have 10 factorial over 4 factorial, which gives you 10, 9, 8, 7, 6. And the other one is just 10 factorial. Again, really big number. So you have to go through all these different scenarios of, well, I'm going to go to Eastern, then I'm going to go to Northern, then I'm going to go to this. What's that?
Yeah, we're gonna get 5. You said there was 4.
Wait, tell me. What's
You said there would be 4 on the bottom, and then you did.
10, 9, 8, 7. Because if it's 6, yes, because I'm not very good at math. This is why I don't do it by hand. That's why I press a button. Thank you. You're right. I should show my work.
Ah, that's good.
10, alpha window, 9, nope, alpha window, 7, 6. 151,200 different ways that you can go from 10 and select and look at 6 different colleges. That's a lot. Again, it gets back to the idea of the actual enormity of numbers. You start to really think about how many different choices there really are as you go through it. And then obviously 10 factorial is even a bigger number. Okay. This gets us, I forget if this chapter gets us to the permutation side. This allows us to do some really little silly things, which is called distinguishable outcomes with repetition or without repetition. And this shows up from time to time with words. This is kind of an oddball thing, but it works out to be really, really quick. If I look at the numbers of distinguishable permutations in the letters Ohio, or the numbers of distinguishable permutations in the word Mississippi, here's what this is doing. How many letters are in the word Ohio? There's 4 of them. So what I'm doing here is I'm taking 4 factorial, and I'm going to divide that by how many letters are repeated. Well, 1 letter is repeated how many times? twice. So one letter is repeated twice, so I divide that by 2 factorial. Which means, how many different patterns could I create out of the word Ohio? Well, it'd be 4 factorial divided by 2 factorial. Or 12, correct. There would be 12 different ways that I can write out the word Ohio. Now, it doesn't mean it has to spell anything. This is kind of what it's doing for you. It's telling you how many different ways you can repeat the words through. Okay. If I look at the word Mississippi, wasn't it always cool when you first learned how to spell Mississippi? You're like M-I-S-S-I-S-S-I-P-P-I. No? I-T. Welcome. All right, oh, we gotta count letters. Ready? 1, 2, 3, 4. Why don't you guys? Is it too early for counting? I know we're ahead of schedule today. Hey, how much do you guys want to bet that tomorrow the bell rings early during first hour?
I'm willing to bet.
I don't know.
Yeah, it's kind of like
put money down on that.
it's kind of like a wash on that one.
Okay, if it reads early, you have to get us food.
No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters in the word Mississippi. How many of those letters are repeated? Well, M is not. I is. 1, 2, 3, 4 of them. S is 1, 2, 3, 4. PP. That's what you're doing. Now this is kind of cool if you had to do this longhand. So you have 10, 9, or 11, 10, 9, 7, 5 multiplied together. And we used to have to do this longhand to write this out. And because things simplify in groups. Or you just press buttons and go that very easy way. Which is fine. Numbers are your friends. Buttons are your friends. Buttons hold shirts together. Yes. What are you laughing at?
Braided.
Rated. Where's your hat?
You sneak this and do this first.
Nico really wants donuts.
I'm sorry, I don't have any. Okay.
What's hot?
What?
Miss a little, miss a lot.
What?
It's the word Ohio with distinguishable patterns.
Those are eyes.
Yeah,
Those are
come
eyes.
on.
Jeez.
Oh, I think I thought it was a T with a line under it because it wasn't quite connected.
Isn't a T with a line under it an I?
But it wasn't like a connected line.
What?
I think you did most of these already, so. Yeah, you did.
Did you guys learn
Yes, we learned how the world works, Emma.
how the world works?
Secret of life.
Just add this to what you have. And we'll go over all of it tomorrow, make sure we're okay on it. I can't imagine this being all that crazy. And then tomorrow we'll start talking about combinations, which is a little bit different. And we'll also talk a little bit about some cards, deck of cards. If you have your own deck of cards, if you want to bring it, go for it, because sometimes it's helpful if you have cards to understand what they are by looking at them also. I just don't have that many deck of cards. I've got like one. I don't know what happened. I have an empty box. I got a bunch of Ryan Sandberg baseball cards. Yeah. Oh, I don't care. I'll use two. I just-
I would win.